The ADOM framework is implemented with the included IDFactory configuration tool. DBA can manage everything about the database through the GUI interface. ADOM is self-contained, so it can run alongside existing functionality with zero impact. ADOM framework includes the following features out of the box: generates log tables and highly tuned triggers, generates stored procedures, functions, and views. Visual Studio add-in, which builds data model objects constructed as partial classes. ADOM handles saves in either transactional or non-transactional processing. ADOM framework handles concurrency out of the box. Both the ADOM database and the target database in this demo are pure Azure SQL DBs. IDFactory GUI used to manage all aspects of the ADOM framework. Demo, ADOM framework configuration basics: log tables, attribute select, which renders the basic object structure of the model, generic search, select all for type tables. In this view of our Azure portal, you can see both the ADOM database as well as the test database we're using for this demo. The ADOM framework can be implemented on any type of SQL database. Here you can see the database diagram showing the basic structure of our test database. This contains the person at the core and demographics about that person in the surrounding table structures. You can also see the foreign keys which tie these tables together. It is the foreign keys which really define the definition of the structure of the XML data resulting from ADOM. You can see the existing tables in our test database in the Object Explorer pane on the left. You can also see the limited stored procedures which exist prior to the atomization process. Most of these are related to the database diagram. In order to give you a true sense of the performance of the ADOM framework, we have populated the tables with a decent baseline of data. We have a stored procedure which renders accounts on each table, as well as some of the sample data, just to show you that there really is data in the tables. Notice there are 100,000 person records, 100,000 emails, 200,000 address records, and 100,000 phone numbers. Next, we have created a stored procedure to render all indexes defined in the database which are not primary keys. As you can see, there are currently no non-clustered indexes in the database at this time. Now we will use the IDFactory configuration tool to implement ADOM on the test database for the first time. Once the initial atomization process has completed, we will refresh the list of tables in the database to show all of the new table objects added by ADOM. Notice they are all listed under a new ADOM schema which the process also created. This just gives better separation for those tables so that users will know they belong to the ADOM process. Now we will go into the ADOM table settings configuration to start setting up the ADOM object structure. Initially, we are just going to set up the person table as a primary object and add a log table to it so you can see the results. Once we have set those, we just re-atomize the database and it will implement the new settings. Once complete, we can refresh the table list again and you'll see the person table now has an associated log table. This log table captures a snapshot of all changes in the table data. Now we will open the highly tuned trigger which manages the log table process. As you can see, it is very simple in nature, but it logs all changes on the table regardless of where they originate from. Now we will go back into the Table Settings Configuration tool within the IDFactory UI. This time we will add all tables as part of the primary object. And we will generate an attribute select store procedure for the person object. The attribute select renders the entire object with metadata that is used by another component of the ADOM framework, which I will demo next. Once the atomization process is completed, we can refresh our stored procedure list to see several new sprocs that have been created by ADOM. I will execute the attribute select sproc for the person table, and you will be able to see the entire object from the perspective of a person. Notice this is populated with sample data for each data type, and it contains several metadata attributes about the columns and tables, which are used by our class generator tool I'll show you next. Here I have a very simple console app which is empty. I simply click on Tools and Generate ADOM Classes. Then I paste the output from the attribute select store procedure, and the component will generate a model containing partial class objects that mirror the XML object created by ADOM. You will notice that the new model folder has been created, which contains the partial classes. I will open the person class first and show you its contents. Notice that it contains properties and methods for each column in the person table. Next, I'll open the email class and show you all of its properties and methods. Notice that the classes are defined as true partial classes. This allows you the greatest extensibility possible while continuing to allow ADOM to update the base classes as needed when there are changes in the underlying data structure. Now we'll go back into the table settings configuration and add the last missing piece, which is the person generic search sproc. I will also set the generate select all setting for the two type tables. Once the database has been re-atomized again, we can refresh our stored procedures listing to find the new generic search for person sproc. I will execute the sproc passing in a person ID of 1 to render the first person in the database. As you can see, the resulting XML contains everything we know about the person in the database across all tables. Notice this person has multiple addresses, emails, and phone numbers listed. Also notice that ADOM has produced select all sprocs for the two type tables. There are sprocs generated in both standard table datasets as well as XML, so the developer can use the approach that they want for these types of tables.